Okay, this is over here. This is okay. I changed it. It's 9709 part 2, paper 4 mechanics, May June 2023, questions 1 and 4. Okay, so we have question 1. A particle of mass 1.6 kilograms is dropped from a height of 9 meters above horizontal ground. So the speed of the particle at the instant before hitting the ground is 12 meters per second. Find the work done against air resistance. Okay, so we have some air resistance. So first thing I'm going to do is I'm going to write my given, and it's pretty simple. The mass is 1.6, h is 9 meters, speed velocity final is 12 meters per second. It's before hitting the ground, so we call it final. Yeah, we want to find the work done against air resistance. So I have explained many times on this channel that work done against air resistance is a term they use in Cambridge. Against air resistance. Okay, so the work done by air resistance and the work done against air resistance. You can say the work done against air resistance is just the reaction to the work done against it's just a reaction to the work done by the air resistance. What do I mean? The work done against air resistance is just equal to negative work done by the air resistance. Okay, this is going to be important for your final answer. The work done against air resistance or the work done against friction should never be a negative answer. So we're going to come back to this in a bit. So now we know that we have resistance force. We know we're working with mechanical energies. Why? Because we're relating height, which is gravitational potential energy, to velocity, which is kinetic energy. And the only relation we have to that is mechanical energy 1 equals mechanical energy 2. But why is this wrong? Why is this wrong? It's because we have a resistance force. So for that reason, we're going to use, instead of saying mechanical energy 1 equals mechanical energy 2, remember, you can use mechanical energy 1 equals mechanical energy 2 only if you don't have friction or air resistance. But when you do have friction and air resistance, mechanical energy 1 plus the work done by the resistance would be equal to mechanical energy 2. Okay? Because you're going to lose some resistance. You're going to lose some energy from the resistance. Okay? So let's see. Let's simplify this. Mechanical energy 1 would be UG1 plus K1 plus the work done by resistance is equal to mechanical energy 2, which is UG2 plus K2. Let's see, what can we cancel out? We know we can cancel out K1 because it's dropped from a height. When you say it's dropped from a height, that means V initial is equal to 0. These are all terms in the external exam, okay? The SABIS doesn't teach this, but when you say it's dropped from a height, and they don't say from rest, when you say it's dropped from a height, that means V initial equals 0, okay? UG2 is going to be 0 because you're hitting the ground, okay? Type. Let's start simplifying a bit. So UG1 is equal to mgh, right? Which is equal to the mass 1.6 times g, which is 10. If it's not specified, you use 10 times h, which is 9, and you get, let's take a look, 16 times 9, 144 joules. K1 is equal to half mv final squared, which is equal to half times the mass 1.6 times velocity final squared, which is 12 squared. Let's put this on our calculator. 0.5 times 1.6 times 12 squared. You get 115.2 joules. Okay, so now we can substitute. We can find the work done by the resistance. So let's go back and substitute. UG1, we figured it out to be 144. Plus the work done by resistance is equal to kinetic energy 2, which is 115.2. Let's subtract 115.2 by 144, and you're going to get that the work done by resistance is equal to negative, how much was that? Negative 28.8. This is the work done by resistance, and it's logical for you to get a negative answer here, okay? But they're not saying the work done by the resistance, they're saying the work done against air resistance. Against air resistance basically means does the opposite. So we said over here, it was this important part, that the work done against is just the opposite, okay? Negative work done by resistance. So the work done against will be equal to negative 28.8. So you're going to get 28.8 joules. This is your final answer. Let me show you the marking guidelines. So we used this method. We found kinetic energy and potential energy. We found the loss, okay, and we found that the work done is 28.8 joules. That's 3 marks, easy, okay? But they said allow if you get negative 28.8 and then using your final as 28.8. Okay, عادي. If you don't explain why, it's fine. But using just, if you got negative 28.8 and just said work done against equals 28.8 without an explanation, that's fine. You don't need an explanation. They said do not allow if you get negative 28.8 as a final answer. Okay, yeah, that's it. That's question 1 done. Now we're gonna go to question 4. An athlete of mass 84 kilograms is running along a straight road. Initially, the road is horizontal and he runs at a constant speed of 3 meters per second. The athlete produces a constant power of 60 watts. Find the resistive force which acts on the athlete. What's the keyword here? It's constant speed of 3 meters per second. What does constant speed mean? It means A is equal to 0. So let's always, whenever you have resistive forces, I always tell you draw the FPD. Okay, so y-axis, x-axis, let's draw it, y, x. Okay, we're gonna start with the weight. Okay, he's moving to the right. Let's call the force, let's call this force E. I always like, when working with power, I call it E. Okay, and backwards we have R, which is the resistive force, and you have N. What do we know? He's running at a constant speed. What does that mean, guys? What does that mean, constant speed? Constant speed means A equals 0, right? So that means when you add up the sum of all forces, you're either going to get MA or 0. But since it's a constant speed, sigma fx is equal to 0. And what does that mean? That means what's on the right is equal to what's on the left. So that means they're canceling each other out, E and R. So E is equal to R. That means to find the resistive force, you can just find E. How do you find E? They gave us the power. They gave us the velocity. Simple as P is equal to FV. Or no, I'm going to continue down here because I need some space. So P is equal to FV. So the force E, okay, or you can say P, you can say, so, but you have to mention, I always say when you use E as a power, you have to mention E is the force. Let me put it up here. E is the force for power. Okay, P is equal to FV, so F is equal to P divided by V. So P, which is 60, divided by velocity, which is 3, which is equal to 20 newtons. So that means resistive force is equal to E, which is equal to 20 newtons. Easy as. The athlete then runs up a 150 meter section of the road, which is inclined at 0.8 degrees to the horizontal. So now he's on an incline, okay? The speed of the athlete at the start of this section of road is 3 meters per second. And he now produces a constant driving force of 24 newtons. Driving force is what we call, this E is actually what they call driving force. The total resistive force which acts on the athlete along this section of road has a constant magnitude 13 newtons. Use an energy method to find the speed of the athlete at the end of the 150 meter section of road. So whenever you're relating going up 150 meters with velocity, with height, with velocity, and you're finding a new velocity, I always tell you use mechanical energy 1 equals mechanical energy 2. But obviously we can't do that. But before I do anything, I'm just going to draw the inclined plane to help visualize it, okay? 0.8 degrees. It's 150 meters long, right? And he starts over here. We know that V initial is equal to 3 meters per second. We know that his driving force is 24 newtons, so he is pushing as well with 24 newtons. We know that the resistance force is equal to 13 newtons, okay? We know also that the distance is 150 meters. And we know that his mass is 84 kilograms from part A. I'll show you now in a second. Over here. Okay, so what's important? We always, when we're relating potential energy with height and velocity with kinetic energy, we always do mechanical energy 1 is equal to mechanical energy 2. That's if there's only weight happening on the force. That's if you have no resistance force. That's if you have nothing else happening. But here, what did we add? We added 2 new things. We added a resistive force, right? And always I tell you, when you have resistive force, you have to add the work done by the resistive force. And we also added the driving force, plus the work done by the driving force is now equal to ME2. You see? So basically, ME1 equals ME1 plus any other work is equal to ME2. That's it. How the formula is written in books, in textbooks, is that they say the change, let me show you. The change, they say delta ME is equal to the sum of all the works. You can use this, but I prefer using this one here because I remember ME1 equals ME2. Oh, but whenever you add any other force, you do ME1 plus this force plus this force, okay? So, what do we need to know here? ME1 is equal to U1 plus K1 plus the work done by the resistive force plus the work done by the driving force is equal to ME2, which is U2 plus K2. Let's start cancelling some things. I know that U1 can be removed and reduced to 0 because we're starting at the ground, right? You can't really cancel anything else. So let's draw a line here and let's start finding K1. I want to make the most of my space, okay? K1 is equal to half mv squared, so it's equal to half, that's v initial, half times 84 times 3 squared, which is, let's do it on a calculator, 42 times 9, it's 378 joules. The work done by the resistive force. We know that the resistive force is 13 newtons, okay? We know it's across 150 meters of displacement, right? So that's the distance. Let me show you so you can kind of understand it better, okay? You have the block over here. We're moving in this direction. This is the movement. The resistive force is in this direction, right? So we know that the work done by any force is equal to force times distance times cosine alpha, with alpha being the angle between the force and the displacement. You can use this, or since you know directly it's a resistive force, it's just negative Fd. Okay, you can use this. But for you guys to understand better, I'm going to use Fd cosine alpha. Always, right? The work done across a force, across any distance, you always use this to be safe. Okay, let's check. Obviously, it's a resistive force, so the angle is going to be 180. So the force is 13 times the distance 150 times cosine 180, which is equal to, let's put degrees, okay? It's equal to 13 times 150 times cosine 180, negative 1950. How about the work done by the driving force? The work done by the driving force is also equal to force times distance times cosine alpha. But here the driving force is actually in the same direction as the movement. So the angle, if it's in the same direction, obviously it's going to be 0, right? So it's 24 times the distance 150 times cosine 0. And let's do this on a calculator. 50. Cosine 0 is just 1, so you don't have to put it. So 3600. Let's put joules. Okay, and we know also we can find U2 and K2. Let's see. U2 is equal to what? MGH, right? طيب, here is the tricky part. MGH. Are we talking about how long the inclined plane is, or are we talking about the height? We're talking about the vertical height. Okay, we're talking about this vertical height, H, right? How do you find H? H, I always told you, H is equal to the length of the plane, length of the slope, times sine of the angle of your slope. So it's equal to the mass, 84 times g, which is 10, times always h when you have an inclined plane is equal to the length of the slope times sine of the angle. So 150 sine 0.8, which is equal to, let's see, 840 times 150. 840 times 150 sine 0.8. It's 1759.234 joules, right? Yeah, okay. K2, we're going to continue. K2 is half mv final squared. Let's find it. It's half times 84 times, we don't know v final squared, so we can just put it as 42v squared, v final squared. Can we substitute everything now? Yes. K1, 378. Plus work done by the resistance force, negative 1950. Plus work done by the driving force, 3600, is equal to U2, which is 1759.234, plus K2, which is 42 v final squared. Let's solve. 378 minus 1950 plus 3600 minus 1759.234 divided by 42, square root, you get v is equal to 2.23 significant figures always. In AS, you always do 3 significant figures, 2.53. Three significant figures because it's not a definitive number, it's a long number. Huh? If it's like a never-ending number, you do three significant figures. That's the rule. So let's take a look over here. We have the way we did it is we found potential energy, we found kinetic energy, we found the work done by the driving force and the resistive force, and this is the work energy equation. They called work energy equation. I just tried this. You don't really have to do it. This all will get you a full mark. Okay, a nice 6 marks. So 1 mark for finding potential, one for kinetic, 1 mark for finding work done, 1 mark for attempt at. So this will get you 2 marks. Okay, yani doing this will get you 2 marks, and then obviously 1 mark for the correct answer. And these are also the accepted answers. Okay, that's it. Thank you so much for watching, and good luck in your exam.